Hi, in this video I will be discussing resistors connected in parallel. So as you can see in this electric circuit, I have three resistors and we call them connected in parallel. To explain that, simply if I have a resistor 1 and let's say a resistor 2, as you can see each resistor has two ends, 1, 2, 1, 2. When I connect the two ends together directly, that's what we call it, resistors connected in parallel. So in our case here for the circuit, I have the two ends of R1 connected with the two ends of R2 and also connected with the two ends of R3. So they're all connected in parallel. Now, the other thing we need to know about resistors in parallel, the voltage across the resistor 1 will be equal to the voltage across the resistor 2 will be also equal the voltage across the resistor 3, and they all in this case equal to the voltage across A, B. Right? So they practically have the same voltage. When I have resistors connected in parallel, the voltage will remain the same all across these resistors. The other thing we need to learn, the total current going through the circuit. So in this case, this is my I total here is going through the circuit. As soon as get to the first junction, it will start split, not necessarily equally, but in a way the current will be shared between all the resistors connected in parallel. So it will go through I1, I2, I3, current through resistor 1, through resistor 2, and through resistor 3. And it will come back again here to come out exactly the same total current we start with it on the top side. So when I add the current through resistor 1 with the current through resistor 2, the current through resistor 3, that will give me the total current through the whole resistor. So if we compare this to our video for resistors in series, we can notice that it's the other way around. In resistors connected in series, the current will be the same, but the voltage will be shared. Here in parallel, the current will be shared, but the voltage will be the same. Now, one more thing we can add to these information we need to learn about resistors in parallel, that the idea of the resistor or the circuit in this complexity to make it simpler. So I want to shrink this circuit to have it one resistor with a battery. So we call that R equivalent. To find R equivalent in parallel situation, it is 1 over R1 plus 1 over R2 plus 1 over R3 in this case, and we will find the inverse for all these numbers. Okay, that will give us the R equivalent. Now to calculate all this, we know it is the voltage equal I times R. That's the Ohm's law. But let me rearrange this formula a bit, and let's say I equal the voltage over the resistance. Now we know that the voltage across the across all these resistors will be the same. So this value here will remain constant. That leaves us to kind of like observe the relationship between the current and the resistance in a parallel connections. It is an inverse relationship. The bigger the resistance, the less current will go through that resistor. The smaller the resistance of the resistor, the bigger the current gonna go through that resistor. All right. So this is the story or the information we need to keep in mind about resistors in parallel. So let's try to solve one simple example to practice what we learned in this video. So I have this electric circuit with the three resistors, 10 kilo ohm, 2 kilo ohms and 1 kilo ohm. As you can see, it is two ends connected directly with each resistor, so it is parallel connection, and they all connected parallel with the battery 9 volt. Now, first of all, asking to calculate the total resistance. So we're trying to find R equivalent. So it is 1 over R1. And we're gonna do it with the inverse. Simply, you're just gonna put the values of each resistance, but don't forget it is kilo, please. You keep that in mind. When you do the calculation, it will end with a 625 ohm. That's the R equivalent. So I can replace this circuit to be like this. It is a battery with one resistor. We call it R equivalent, and that's the 9 volt. Okay. Now, the second item in this question is the total current in the circuit. So let's find how much is the total current going through this circuit. Well, we're gonna apply Ohm's law. I total will give me the voltage divided on the R equivalent, and it is 9 divided on a 625. That will give us, okay, that is 14.4 milliampere. All right, cool. So I will have a total current going through this circuit and coming back here, the same value. It is the 14.4 milliamp. We said the current will be shared between these resistors. Okay, and that's the third item. Calculate the current through each resistor. All right. First of all, we can predict that, as we said, the relationship between the current and the resistors in a parallel connections, it's an inverse relationship. So the smaller the resistance, the bigger the current, which means R3 in our case here should take most of the total current. And let's see, let's examine that. So if I want to find I1, it will be V over R1. And doing that, as we know, the voltage will be the same. It's 9 volt. So let's write this down. 9 over 10 kilo. Doing the math, that will give me 0.9 milliampere. If I want to find I2, we're going to do V over R2. Just quick to save the time. It is 4.5 milliamps. Okay, that's good. It is definitely 2 kilo ohm is smaller than 10 kilo ohm, and we can see that the current is rising. Let's see for the last one, the third resistor. So I3, it is V over R3, and if we do the math, 9 over 1, that will give me 9 milliampere. Yes, it is true. So we can see the relationship between the current and the resistance in a parallel, it's an inverse relationship. R3 is the smallest, getting the highest current. That's one. The other thing can help us to confirm our calculation. If you add 9 milliamps with the 4.5 milliamps and 0.9 milliamps, it's the three currents going through the three resistors must give you back the total current, which is 14.4 milliamps. So I hope this video useful to build up the concept of resistors in parallel. What is it? How you can identify it? And the concept, the voltage will be the same, the current will be shared, and how you can calculate the R equivalent. And with this example, things helping you more. Thank you.